Hello, we are doing some questions on the question is from meromorphic function and complex analysis. Okay, so now let us see what the question says, that let sigma be an let omega be an open subset of C. Suppose f is a meromorphic function on omega having exactly one zero at z0 and exactly one pole at z1. Okay. So further, m is the order of the zero at z0 and n is the order of pole at z1. If our g be another function which is running from omega to c, is analytic, and d is an open disk with center a and radius r, such that z0 and z1 belongs to d and the boundary of d is a subset of sigma of omega. Okay, so then show that 1 by 2 pi I integral, the limit is gamma f dash z by fz gz dz equals to m into g of z naught minus n into g of z naught, where our gamma t is a plus r e to the power 2 pi it for 0 less than equals to t less than equals to 1. That means our t is lying between 0 to 1. Okay, so let us see what can we do for this. So the informations are, the f is meromorphic on omega with a 0 of order m at z0 and a pole of order n at z1. G is analytic on omega and gamma is the boundary of the disk D containing z0 and z1. Okay, so let us analyze the integrand. Okay, so our integrand is what? That is f dash z by fz into gz. So since our f has a 0 at z0 and a pole at z1, we can express our f locally as f of z, that is equals to our z minus z0 to the power m h z, where our h is analytic and we can say that our h of z0 is not equals to 0. Okay. So near z1, what will happen? Near z1, we can say that our z will look like kz by z minus z1 to the power n, where our k is analytic and our k of z1 is also not equals to 0. Okay. So now we are going to compute f dash by f. So at z0, what we will get? Let me change the color. Yeah. So at z0, what will happen? Our fz will be equals to z minus z0 to the power m into hz, that is equals to f dash z by fz equals to only m by z minus z0 plus h dash z by h. Can you see that how we got that? Because our f dash z will be what? We have to use the derivative of u into v form. So we should get m into z minus z naught to the power m minus 1. So by derivating using that, so we should get m by this part and hz will be there. So hz will be cancelled out. So we should get m by z minus z naught. And plus the second part will be what? That should be z minus z naught to the power m part will be constant. So we should get cancelled out in both of the numerator and denominator. So we should get a derivative of hz with respect to z. So that is our h dash z by hz. So that's why we should get this thing. Okay. So now we are going to find at z equal to 1 what will happen. So at z equal to 1, we should get f of z equals to our kz by z minus z1 to the power n. And we should know that our h of z0 is not equals to 0. So we should get this. Okay. So now we are getting this for this. So our f dash z by This will be what? That should be minus n by z minus z1. The same algorithm will be used for what is used in z naught. Okay. So we should get this thing plus k dash z by kz. So since we know that our k dash z by kz is analytic near z1, since our k of z1 is not equal to 0, we know that. So thus our f dash z by fz has a simple pole at z with residue m and a simple pole at z1 with residue minus n. Okay. So now we are going to apply the residue theorem in my new integrand. So what we should get, that will be, as we know that our g is, since g is analytic everywhere, so by the residue theorem, so we can use the residue theorem here. So by the residue theorem we can say that residue of f dash by f g at z naught plus, that should look like residue of f dash by f g z1. Okay. So we know that residue at z naught, that is the residue of this thing, that is the first part, that is residue of f dash by f g into z naught will be limit z tends to z naught, z minus z naught into m by z minus z naught plus h dash z by hz into g of z. So that will be what? So we can easily see that our z minus z naught will be cancelled out from numerator and denominator in the first part. So we should get only and our h dash z by hz, and this part will be vanished. So we should have only m into g of z naught. So now for the second part of this integral, so we should get the second residue, which is f dash by f into g at z1. We should get limit z tends to z1. We should get z minus z1 into minus n by z minus z1 plus, that should be k dash z by kz into our that is g of u. So now from this we can easily just use the same algorithm in the first limit. So we should get in the previous limit, so we should get this thing. So that will be 1. Yeah. So we can easily say that our integral of this thing, that means 1 by 2 pi I integral limit at omega, and our f dash z by fz gz dz is equals to these residues, and the residues is equals to, we can easily see that that would be, okay. Hope you understood, guys. Thank you.